Hello everybody, it's Amell, and today I'm going to show you how to solve the closest binary search tree value problem. It says, given a non-empty binary search tree and a target value, find the value in the BST that is closest to the target. For example, they give you this tree and this is the target, and the value in the tree that is closest to the target is 5. Example 2, they give you this tree and this is the target. The value that is closest to the target in the tree is 4. So how can we solve this problem? We can solve this problem in several ways. We can solve it iteratively or recursively, or we can solve it taking advantage of the property of the BST, or we can solve it not taking advantage of the property of the BST. In this case, I'm going to solve it iteratively, and I'm going to take advantage of the property of the BST. As you know, a binary search tree has the property that all the values to the left of the root are less than or equal to the value of the root, and all the values to the right of the root are greater than the value of the root. So I'm going to take advantage of that property, and I'm going to use a while loop because I want to do this iteratively. So what I'm going to do is that I'm going to have integer result gets a value of root that value. I'm gonna make the assumption that the value of the root is going to be the closest one initially, and then I'm gonna have while root is not equal to null, then as long as root is pointing to something, then I want to check. So I'm gonna say if math that absolute value of root that value minus the target is less than math that absolute value of the result minus the target. What does that mean? It means that I found a new value that is closer to the previous value I had as the closest. So I want to update. I'm gonna say that the new result gets a value of root that value. This value at the root is closer. And then I want to move left or right depending on the value of the root. So I'm gonna say now root gets a value of target is less than root that value. If that's the case, the target is to the left, so I have to go left. So root gets a value of root that left. Otherwise, I go right. So I say root gets a value of root that right. And by the end of the loop, I return the final result. Return result. So as you know, this is using the property of the binary search tree. And notice that I'm not checking if the tree is empty, because the problem says that the tree is non-empty. But in an interview, the tree might be empty, so you need to check if the root equals null. So I'm gonna run the code, accept this. So I'm gonna submit a solution. Alright, so this is working perfectly. The time complexity is big O of h, where h is the height of the tree. Please press the like button. Don't forget to subscribe, and see you next time.